Hello everyone, I'm Vanessa. Let's take a look at this question here. What is the largest 3-digit number that has all of its digits different and is equal to 37 times the sum of its digits? Okay, so let's call this 3-digit number as A, B, C. And A is in the hundreds place, B is in the tens place, C is in the ones place. And let's put them in the respective value. So 100A, okay, plus 10 times B, so 10B plus C equals to 37 times the sum of its digits, A plus B plus C. So as we expand and simplify this, okay, what do we have? What equation do we have here? So 37 times A, 37A, 37 times B, and okay, let's bring all the A on the left hand side. You see that this is what we will get, 37B minus 10B, so plus 37C minus C. So here we have 63A equals to 27B plus 36C. And then we see that they have a common factor, 9. So we continue to simplify that to become 7A equals to 3B plus 4C. Now, this is our equation here, okay? And it is going to be our reference when we try and error for certain values of A. Now, looking at this, 7 is actually 3 plus 4, right? So meaning to say that if they are all of the same value, this equations becomes valid. That means A equals to B equals to C, these equations will be valid. But in this case, since we are asked for different numbers, so that cannot happen. Okay, so from these equations, we know that, okay, all these numbers, 111, 222, 333, and so on and so forth, up to 999, okay, will satisfy this condition, except that they are not different digits. They are equal digits. So this one cannot be the answer. Alright, so 999 cannot be the answer because I want all the digits to be different. So with that, okay, we have to try and error here. Okay, since 7A is the greatest number here, so A cannot be 9. If A is 9, the only way for these conditions to hold is that B and C must be 9 as well. So let's try A equals to 8. Okay, let's try A equals to 8. Then we would have 56. Okay, 7 times 8 is 56. Equals to 3B plus 4C. And now what we see is that, okay, I see some beautiful numbers here. Okay, so 3B equals to 56 minus 4C. Alright, and 56 and 4, they have a common factor. So meaning to say I could further factorize it into 4 and then 14 minus C. And what is so important about this equation is that it means that B must be a multiple of 4. Okay, B must be a multiple of 4. But we have already used up A equals to 4, so B cannot be 4. So B has to be 4 in this case. Okay, so B cannot be 8. But if B equals to 4, can this equation still hold? Because if B equals to 4, then we would have to say that, okay, so this will be 3 times. So 3 times 4 equals to 4, 14 minus C. But C, would give us 11. And C cannot be a double digit here. So that cannot be true. Okay, so now we have to try A equals to 7. So if A equals to 7, so 7 times 7 equals to 3B plus 4C. Okay, so as I rearrange, I could have say is 3B plus 4C equals to 49. Okay, and what I could do right now here is that I could put it as 4C equals to 49 minus 3B. Okay, so 4C equals to 49, or I could split it as 48 plus 1, okay, minus 3B. Alright, so I could further do it in this manner, plus 1 minus 3B. Now, the reason why we are doing that is to check for any suitable values for B and C if A equals to 7. So I could divide by 4 throughout. So C equals to 48 divided by 4 is 12 plus 1 minus 3B bracket over 4. So now, for this equation to be valid, we need to have B as, okay, B must be 3 or 7. 3 or 7. But we cannot be 7 because we have already used A as 7. So B, if B equals to 3, okay, let's take a look. So C will be 12 plus 1 minus 3 times 3. But that will give us 10. Alright, that will give C as 10. And again, C cannot be a double digit here. Right, so in this case, we cannot. So let's try. Okay, now bear in mind our initial equation here. 3B plus 4C. Now that we know that 9, 8, 7 for A is not possible, let's try for A equals to 6. So A equals to 6 is 7 times 6 equals to 3B plus 4C. Or we could say that 42 equals to 3B plus 4C. So applying what we have gone through just now, we could also say that here I want it to be 4C equals to 42 minus 3B. Okay, so C equals to, oh, okay, I think in this case we make it as 3B equals to 42 minus 4C. So now I want to simplify further as 42 divided by 3 minus 4 over 3C. So it's 14 minus 4 of 3C. Now for this equation to be valid, C must be a multiple of 3. Okay, so C could be equals to 3. In this case, gonna be 6 because we have already used 6, or C could be 9. Alright, so if C equals to 3, then B equals to 14 minus 4 out of 3 times 3. You see that B will give us 10, which is not possible. Let's reject it. Okay, so let's try C equals to 9. So C equals to 9, B will be 14 minus 4 of 3 times 9. So I have 12, 2. So that is valid, or this equation holds true. So we have A equals to 6, B equals to 2, and C equals to 3. Oh, sorry, C equals to 9 in this case. Okay, c equals to 9. This is acceptable. Alright, so the answer is 6 to 9. Yes, why do I have to spend 10 minutes recording this one? Where some argue that, well, we could have solved it using some, listing and try and error. Yes, undeniably you can, but the thing is, if I were to tweak the question a bit, such that instead of asking the question just now, I'm asking for a 3-digit number that is greater than 400 but less than 500, and it has all these digits different and is equals to 37 times the sum of the digits. Would you be able to answer me using the listing and try and error method? It is almost impossible, right? Because this number is between 400 and 500. So listing would become almost impossible because it will be taking up too much time. So with that, we need this formula. And I'll go through that, that question in the next video. And see you again. Vanessa signing off, and goodbye.